guys, we are moving on in science today. We're finally taking Newton's laws and putting them to the side. We've been doing those for 2 weeks, so it's time. And we are going to move on to lesson 3. So you will need your science books today, and they will need to be open to page 75. But before we get into the actual reading of these pages, I brought in a physics expert to explain these concepts to y'all, to give you an idea of what we're working with, and it'll make reading about it a little bit easier. And it's not Tucker, it's actually someone who knows what they're talking about.
Hello 5A and 5B. Today I'm going to be teaching you about adding forces, balanced forces, and net force. So, first one, adding forces. I'll use this manatee that I was given for my 11th birthday to demonstrate. My mom is a great gift giver. So if I push on this manatee just a little bit across the desk, it'll move across the desk rather slowly. But if I have Miss Muller help me push it across the desk, it'll move across the desk faster. Okay, so those two forces are adding together and coming to act on the manatee as one force that makes it move faster. Okay, next thing is balanced forces. So I can push on the manatee to make it go to the right and to the left, but if I push on it in both directions at the same time, the forces balance each other out. So if I go like this, the manatee is not moving because those forces balance each other out, they cancel. So, and also, gravity right now is pulling the manatee down, but the desk is pushing it up. That's why it stays still. Those forces are equal and opposite, so they balance each other out. That's why it stays still, and it's not floating off into the air. But that does bring me to net force. So whenever the manatee is stationary, the net force is 0. So right now, gravity and the force from the desk cancel each other out. The net force is 0. If I push it this way, the net force now becomes to the right with however much force I'm giving it right here. You don't have to consider gravity in the desk because those two cancel each other out. Net force is just a fancy way of referencing the forces that are unbalanced on an object. So because this one does not have a counterpart that's canceling it out, like me pushing this way, that is what makes it part of the net force.
Have you ever asked a friend to help you push something heavy? By pushing together, two people can combine their forces into a single force. This combined force can have a bigger effect. When two forces act on the same object and have the same direction, their strengths can be added together. The combined force will point in the same direction as the two single forces. For example, if two people lift a box together, their forces can be added because both forces point upward. If each person applies a force of 100 newtons, their combined force will be an upward force with a strength of 100 newtons plus 100 newtons, or 200 newtons. So think back to the video with the manatee. When Gregory pushed the manatee, it moved, but not very fast. When we had two people pushing the manatee, it moved a lot faster. Our forces combined. Now, I don't know how strong our forces were, but I'm feeling pretty strong. I feel like, they were good. But another thing to think about is when y'all have to move the table out of Miss Spafford's room or move a desk to a classroom. When you try to do it by yourself, yes, you can do it, but it's a lot harder versus when your number partner helps you, it moves it a lot easier as long as y'all are going in the same direction. Now, if you're not communicating and one of you's pulling up and pushing down, that desk is not going to go anywhere. You both have to be lifting up on the desk. When you hold a book in your hand is pushing the book up. At the same time, the Earth's gravity is pulling the book down. The two forces push against each other just enough to keep the book from moving. Two forces of equal strength that combine to act on the same object but in an opposite direction are balanced. Balanced forces cancel each other out and cannot change the motion of the object. Several forces can be balanced at the same time. For example, several ropes may pull on a camping tent without causing a change in motion. The total of all the forces acting on a body is called the net force. When the forces acting on a body are balanced, the net force is 0. In the video, when Gregory pushed the manatee to the left or to the right, it only moved in that direction. But when he pushed the manatee with equal force from both directions, the manatee didn't move at all. That's because the forces were balanced. When something is balanced, they cancel each other out. So you're just as strong as that other force. Which brings me to your assignment. Arm wrestling. Yes, you heard that right. That's your job today. More specifically, I want you to find someone in your house that you can arm wrestle with. Not anyone under the age of 3. Nobody needs to break siblings' arms over this. It's not that big of a deal. But I want you to have an arm wrestling match. And as you're doing that, I want you to think about the balanced forces and the unbalanced forces and how that applies to the game of arm wrestling. After you're done, I want you to either send me a video explaining how these forces apply to arm wrestling, or write down on a piece of paper how they apply to arm wrestling and send it to me in a picture. But also equally as important, I want to know who won. Good luck! Let me know how it goes. One more thing. Wash your hands before and after your arm wrestling match because germs are real and we need to flatten the curve so we can go back to school soon because I miss y'all. Bye!